Step outside tonight, find a western horizon. Wait for the sun to go down. Then, wait a few minutes more, until the sky begins to darken, and the first faint objects push through the twilight. 2 of them will be unmistakable. 2 brilliant points of light, burning side by side in the west, brighter than anything else in the sky. They are not stars. They are worlds, Venus and Jupiter. And right now, in the evenings of early June 2026, they are drifting toward each other across the dome of the sky, in what astronomers call a conjunction. The geometry is simple. 2 planets, on their separate orbits, reaching a position from which they appear, from our vantage point on Earth, to nearly touch. It happens every year or so. This particular meeting is one of the most visually striking in years, and most people will not look up. That is not the strange part. The strange part is this: the conditions required for a human being to stand on a solid surface, look west at twilight, and watch 2 planets converge in silence. Those conditions are so improbable, so layered with contingency, so dependent on an extraordinary chain of coincidence, so stretching back billions of years, that the real question is not why we are watching. The real question is why, across a universe of hundreds of billions of galaxies, apparently no one else is. There is a word for what you feel when you first truly understand that question. Not wonder, not fear, exactly. Something quieter than fear. Something that arrives slowly, the way a cold front moves in. First the change in the air, then the darkening. Then the realization that the sky has been changing for a long time before you noticed. That feeling has a name in this particular corner of physics. It is called the Fermi Paradox, and 2 planets drifting together in the evening sky may be the most elegant entry point anyone has ever found into the deepest unsolved problem in science. What follows is not a sky-watching guide. What follows is an attempt to trace the thread. From the beauty of that conjunction, backward through time and forward through implication, all the way to a silence that gets harder to explain the longer you think about it. Let's start with what you can see, and then let's ask why you're the only one looking. Venus, the inner planet, is the brightest object in the night sky after the moon. Its brilliance is not because it is large, it is smaller than Earth, but because its cloud cover is almost perfectly reflective. Light from the sun arrives at Venus and bounces back into space with extraordinary efficiency. From Earth, it burns with a cold, white intensity that looks almost artificial. You might mistake it for an aircraft if it weren't absolutely motionless. Jupiter is the other anchor. The largest planet in the solar system, a world so massive that more than 1,300 Earths could fit inside it. Glowing not only by reflected sunlight but by the faint residual heat of its own formation. Energy still radiating outward from the collapse of gas and dust that built it 4.5 billion years ago. Even at hundreds of millions of miles distance, it is unmistakable. A pale, steady cream-colored light that does not flicker the way stars do, because its disk is wide enough that atmospheric distortion cannot make it dance. In the evenings of early June, these 2 worlds are converging in the sky. Each night, they are measurably closer. By the 9th of June, they reach their closest apparent approach, separated by less than half a degree of arc. Less than the width of the full moon. Close enough that both fit inside the field of view of a pair of binoculars, along with the 4 moons of Jupiter that Galileo first resolved in the winter tour of 1610. Io, Europa, Ganymede, Callisto, arranged in a shifting line beside the giant planet, repositioned every night as they complete their individual orbits. It is, by any measure, a spectacle, and it costs nothing. It requires no equipment. It requires no specialized knowledge. It requires only that a human being step outside after sunset and look west, which raises a question that sounds simple and is not. How many creatures, on how many worlds, have ever done exactly that? Stood under an open sky, looked up, and asked what they were seeing. The answer, as far as we can determine after decades of searching, is one. One species, on one world, in one solar system, in one corner of one galaxy among hundreds of billions. One. That number should trouble you more than it does. Here is the comfortable version of the story. The universe is large, incomprehensibly large. The Milky Way alone contains somewhere between 100 billion and 400 billion stars. Observations from missions like Kepler suggest that most of those stars host planets. Many of those planets orbit within zones where liquid water could exist on their surfaces. Given those numbers, the reasoning goes, life must be common. Intelligence must have arisen elsewhere. Other civilizations must exist. They are simply too far away for us to have found them yet. This explanation has the advantage of being emotionally satisfying. It preserves our intuition that the universe ought to be full of minds. It says, wait long enough, search hard enough, and we will find them. It is the version that gets told in textbooks, in popular science, in science fiction. It feels reasonable. And for a long time, it seemed sufficient. Then the silence continued, and the silence became harder to explain. The physicist Enrico Fermi, during a lunch conversation at Los Alamos in 1950, posed a question that has haunted astronomy ever since. If the galaxy is old, and if intelligent life arises naturally from the conditions that produce planets and chemistry and time, then civilizations should have had billions of years to develop, expand, and make their presence known across interstellar distances. Even at a small fraction of the speed of light, a civilization with the technology to cross the gap between star systems could, in principle, colonize the entire Milky Way within a few tens of millions of years. Tens of millions of years sounds enormous. On cosmic timescales, it is a rounding error. The galaxy is 10 billion years old. A civilization that emerged even 1 billion years ago, and 1 billion years ago, Earth had not yet developed complex multicellular life, would have had time to reach every star in the Milky Way dozens of times over. Where are they? That is the Fermi Paradox. Not a paradox in the logical sense. A paradox in the sense of something that should be true given what we know, but appears not to be. Over the following decades, astronomers developed an answer. If we could not detect civilizations directly, perhaps we could detect their signals. Radio waves travel at the speed of light. A technological civilization producing radio or television broadcasts, or deliberately transmitting signals toward other stars, would be leaking electromagnetic radiation into space in patterns too structured to be natural. We built instruments to listen. The search for extraterrestrial intelligence, the long program of scanning the skies for anomalous signals, began in 1960 with a project called OSMA, pointing a radio telescope at two nearby sun-like stars. It found nothing. Decades of increasingly sensitive searches followed. They found, with one famous and still unexplained exception, nothing. The exception arrived in 1977. An astronomer named Jerry Eman was reviewing data from the Big Ear radio telescope at Ohio State University when he noticed a signal unlike anything in the records. A narrow-band transmission, the kind that natural phenomena do not produce, arriving from the direction of the constellation Sagittarius. It was so striking that Eman circled it in red ink on the printout and wrote a single word in the margin. Wow. The signal lasted 72 seconds, exactly as long as the telescope scanning window allowed. It has never been detected again. No confirmed source has ever been identified. It remains the most compelling candidate for an extraterrestrial transmission ever recorded, and it remains unexplained. One signal, 72 seconds, 49 years of silence since. This is where the story should pivot toward explanation. A hypothesis should step forward, account for the data, and resolve the tension, and one did. It was persuasive enough that it became, for a time, the dominant interpretation. Perhaps the thinking went, the universe is simply too large. The distances between stars are not merely vast, they are actively hostile to communication, even radio waves traveling at the maximum possible speed, take years to cross the gap to the nearest star, decades to reach the nearest star systems that might host habitable planets, thousands of years to cross the galaxy. A civilization broadcasting into space from a star system 1,000 light years away sent those signals 1,000 years ago. If they are not broadcasting continuously, we might simply be missing the window. If their civilization collapsed after a century of radio output, those signals passed through our region of space long before our instruments existed to receive them. The galaxy, on this view, is full of brief candles, civilizations that bloom and fade on timescales too short to overlap with one another. The silence is not emptiness, it is timing. Ships passing in the night, if the ships are separated by thousands of years and millions of miles, and the night lasts forever. This explanation held for a long time. It is internally consistent. It does not require life to be rare. It does not require intelligence to be unique. It simply requires that communication across interstellar distances is as difficult as physics suggests it should be, and it felt correct in the way that emotionally satisfying explanations often feel correct before the evidence has finished accumulating. Then, the evidence continued accumulating, and the timing hypothesis began to show its fracture lines. A civilization transmitting for only a century might be easy to miss. A civilization transmitting for 10,000 years would be harder to miss. A civilization transmitting for 1,000,000 years would be nearly impossible to miss, if our detection methods were even marginally adequate. But the timing hypothesis does not just require civilizations to transmit briefly. It requires that no civilization in the galaxy has survived long enough to become a persistent, detectable presence. Not one, not in 10 billion years. Because a single civilization that arose early enough, expanded persistently enough, and survived long enough would have left signatures we could not fail to detect. Not just radio signals, but physical structures, waste heat, altered stellar environments. The engineering projects of a sufficiently advanced civilization would rewrite the appearance of entire star systems. We have searched for those signatures too. The results are the same, nothing. The timing hypothesis, taken seriously, requires that every civilization in the galaxy, every one that might have arisen over billions of years, followed the same trajectory. Emergence, brief, flourishing, silence. Either they failed to survive, or they failed to expand, or they failed to want to. Every single one. The uniformity that explanation requires is itself an explanation that demands accounting, and this is where the geometry changes. Not the geometry of orbits, the geometry of probability. If you look at what is actually required to produce the view from your backyard on a June evening, 2 worlds visible, a clear horizon, a solid surface to stand on, an atmosphere thin enough to see through, eyes capable of detecting light in the visible spectrum, a cognitive architecture capable of recognizing what it is seeing and wondering about its origins. You begin to enumerate a list of prerequisites that extends a very long way back in time. A star of the right mass, stable enough to burn for billions of years without violent variation. A planetary system arranged with the right architecture. A large outer planet like Jupiter, acting as a gravitational shield, deflecting comets and asteroids that would otherwise bombard the inner planets with catastrophic frequency. A world at the right orbital distance, within the narrow habitable zone where liquid water can persist on the surface. A world of roughly the right size, massive enough to hold an atmosphere, not so massive that the atmosphere becomes a crushing shroud of hydrogen. A large moon, stabilizing the axial tilt, preventing the kind of chaotic precession that would cause catastrophic climate swings over geological time. Plate tectonics, cycling carbon through the atmosphere and oceans, maintaining the chemical balance that keeps temperatures in a range compatible with complex chemistry. And then billions of years of mostly uninterrupted time, during which the slow, blind process of evolution could accumulate complexity from the most primitive self-replicating molecules, all the way to creatures standing in a backyard looking west, wondering about the lights in the sky. Each of those conditions has a probability. Each of those probabilities is less than 1. When you multiply probabilities that are each less than 1, the product decreases. The more conditions you add, the smaller the final number becomes. The rare Earth hypothesis, developed by the paleontologist Peter Ward and the astronomer Joe Kirkpatrick, argues that the combination of factors required to produce not just life, but complex, multicellular life capable of intelligence is so specific and so improbable that Earth-like planets may be genuinely uncommon across the galaxy. Not impossible, not unique necessarily, but uncommon enough that the nearest equivalent might be separated from us by distances that make meaningful contact implausible. Some researchers argue the calculation is even starker than that. Not just the conditions for life, but the conditions for the specific kind of cognition required to build instruments and ask questions and listen for signals. Those conditions may depend on contingencies so numerous and so specific that replicating them elsewhere, even across a galaxy of hundreds of billions of stars, may be genuinely improbable. We are left with a branching structure. Either the universe is full of life that we have simply failed to detect despite decades of increasingly sensitive searching, or life is common but intelligence is rare. The leap from simple chemistry to self-aware cognition is a barrier that most biospheres do not cross. Or intelligence is common, but technological civilizations are short-lived. Something about the development of complex technology carries within it the seeds of self-destruction, and civilizations regularly collapse before they can become detectable. Or something else, something we have not named, is suppressing the emergence or persistence or detectability of intelligence across the galaxy. The astrophysicist Robin Hanson formalized this last category as the Great Filter. The idea that somewhere along the chain from simple chemistry to galaxy, spanning civilization, there is a step so difficult, so unlikely to be crossed, that virtually nothing makes it through. The disturbing implication is one of location. The Great Filter is either behind us or ahead. If it is behind us, if the emergence of complex life, or intelligence, or technology is the rare event, then we may be among the first minds in the galaxy, perhaps in the universe, early arrivals in a cosmos not yet populated with our kind of awareness. If the filter is ahead, it means the difficult step has not yet been encountered. It means civilizations regularly reach our level of development and then stop. Something ends them, something universal enough to have ended every civilization that came before us. And we are right now approaching it. The evening sky does not offer guidance on which of these possibilities is correct. It offers only the conjunction, two planets drifting closer across the western twilight, indifferent to the question. There is, embedded in that view, something worth holding in mind. The fact that you can see Venus and Jupiter meeting in the sky tonight depends on a chain of coincidence so long and so precisely maintained that it strains the capacity for honest accounting. The orbital resonances of the solar system, the precise distances that place both Venus and Jupiter within the habitable viewing geometry from Earth's surface, the atmospheric clarity that allows light to reach your retina unobstructed, the evolutionary history that produced eyes, sensitive to exactly the wavelengths of light those planets reflect. These are not givens. They are the accumulated result of billions of years of extraordinarily specific events, any one of which, gone differently, would have produced a world from which that view was simply impossible. On a world with a denser atmosphere, both planets would be invisible. On a world in a tighter orbit, the geometry would be wrong. On a world around a different kind of star, the light itself would be different. On a world without complex nervous systems, no one would know what they were seeing. The view from your backyard is not the default condition of the universe. It is the exception, which means the question is not merely where everyone else is. The question is whether anyone else, anywhere in the observable universe, is standing outside tonight and watching two bright worlds drift together across a darkening sky, and whether they are wondering, as you may be, what it means that no one appears to be watching back. Here is the part that becomes difficult to sit with. When you look at Venus and Jupiter in conjunction, you are not seeing them where they are. You are seeing where they were when the light you are detecting left their surfaces. Jupiter is so far away that its light takes more than half an hour to reach you. Venus, closer, takes only a few minutes. You are looking at a scene that does not exist in the present tense. You are reconstructing the past from photons that have been traveling since before you looked up. This is true of everything in the sky. The stars you see tonight are reconstructions. The light from the nearest ones is years old. The light from the most distant visible stars is thousands of years old. The light from the nearest large galaxy took 2.5 million years to reach your eye. You are never seeing the universe as it is. You are seeing it as it was, across a sliding window of different pasts, all arriving simultaneously in the present moment. Now extend that observation to the search for intelligence. A signal from a civilization 1,000 light years away would have been transmitted 1,000 years ago. That civilization may not exist anymore, or it may have changed beyond recognition, or it may be there, still transmitting, but the signal has not yet arrived. The galaxy is not a static map. It is a 4-dimensional object, and we are peering into it through instruments sensitive to a narrow slice of the electromagnetic spectrum over a period of decades, on a planet that has been technologically capable of this kind of search for less than a century. Less than a century against 10 billion years of galactic history. The search is not complete. It has barely begun. And yet the silence continues, and the silence says something. There is another event, coming in the same evening sky that most casual observers will not notice. And that, once you know what you are looking at, is difficult to stop thinking about. In mid-June, following the conjunction, the crescent moon enters the western sky and joins the remaining planets in a loose alignment. Mercury low on the horizon, then Jupiter and Venus, then the moon, then Regulus, the bright heart of Leo, threading together in a line across the twilight. 5 objects, arranged by the simple mathematics of orbital mechanics, framed in the last light of a June evening. 5 objects, each of which has been circling the sun for the same 4.5 billion years. The same mathematics that produced that alignment also produced the conditions for you to observe it. The same clockwork that places planets in predictable positions, places observers in specific windows of time and space, from which those positions become meaningful. The crescent moon, in those evenings, will show what is called Earthshine, the dark portion of the lunar disk, lit not by the sun but by sunlight, reflected from Earth's own surface, crossing the gap between worlds, lighting the moon from behind, and then returning to your eye. You will be seeing your own planet's light, bounced off another world, return to you across space. It is, in the most literal sense, a mirror. The universe reflecting Earth back at itself. Most people will miss the conjunction entirely. Most will not go outside that at the right time, in the right direction, with the right patience, to let their eyes adjust to the twilight. Of those who do look, most will see 2 bright stars and move on. A smaller number will pause long enough to recognize that they are not stars. A smaller number still will wonder about the geometry. Why those 2? Why now? What that arrangement means? And a smaller number, even than that, will follow the wondering far enough to arrive at the question that the geometry implies. Are we alone in the universe? Not as a rhetorical question, as an empirical one. Not a question for religion or philosophy, but a question for science, for measurement. A question that our species has been attempting to answer for less than a single human lifetime. and has so far answered with one deeply ambiguous signal from 1977 in decades of silence. Jupiter will not be in the evening sky much longer. By July, it passes into conjunction with the Sun, not a planetary conjunction like this one, but a solar conjunction, the planet moving behind the Sun from our perspective, lost in the glare for weeks. The evening sky will lose its second anchor. Venus will remain for a while, brilliant and alone in the west. Then it too will move through its phases, pulling away. The lineup that exists right now, this particular arrangement of worlds visible from this particular planet, in this particular moment of late spring, is temporary, like all arrangements, like all moments, like possibly the conditions that produced the observers who noticed it. What we do not know vastly exceeds what we do. We do not know whether life has arisen elsewhere. We do not know whether intelligence, as a phenomenon, is confined to a single lineage on a single world, or whether it is a general feature that emerges wherever the right conditions hold long enough. We do not know where the great filter is. We do not know what ended the civilizations that may have preceded us, if any did. We do not know whether the silence of the galaxy is the silence of an empty room, or the silence of a room in which everyone is very carefully not speaking. What we do know is the geometry. We know the orbits. We know the distances. We know that two worlds, on their independent paths around the same star, will continue to produce conjunctions long after any observer has stepped outside to note them, long after the instruments are gone, long after the questions are gone. Venus and Jupiter were converging in evening skies before our species existed. They will converge again long after we are finished. The mathematics does not require a witness. The alignment does not require understanding. Two bright lights in the western sky, drifting toward each other on schedule, as they have for billions of years, and will for billions more, with or without anyone to look up and wonder what they mean. And that is the thing about the sky that is difficult to hold in the mind for very long. Its indifference is not malevolent. It is simply structural. The universe does not require observers. It does not produce observers because it wants them. It produces them, apparently, when conditions arrange themselves in a specific enough way, and hold long enough for the blind accumulation of complexity to overshoot into awareness. And then those observers look up, recognize the geometry, name the planets, build the instruments, and discover that the universe is silent in exactly the way it would be if they were alone in it, or in exactly the way it would be if something was watching them notice. We do not know which. Go outside tonight, look west, find the two brightest lights in the sky, watch them for a while. Not because there is something to accomplish by watching, not because the universe will notice, but because the conditions required to produce that moment, a clear sky, a dark horizon, two eyes sensitive to visible light, a nervous system complex enough to wonder, those conditions are rarer than we once thought, and the capacity to recognize their rarity is rarer still. Two worlds converge in the western sky. They have been doing this for longer than our planet has had complex life. They will keep doing it long after the last instrument falls silent. The question is not what they mean. The question, the one that does not close, the one that the geometry keeps reopening, is whether anywhere else in the observable universe something is watching them, and what it would mean if the answer is no.